Yeah, g'day and welcome back. If you're a long-time viewer of my channel, you know that I bought this Jones and Shipman 540 surface grinder a while ago. And apart from a few minor maintenance issues like lubricating the spindle bearings and replacing a bent pair of hydraulic rods, I've now got it working. However, my first test grinds were kind of disappointing. So let's take a bit of a look at it and see if we can improve that today. Now the very first thing I ground on my surface grinder was this block. Did both sides. Let's take a quick look at how parallel it ground. Zero there. So we'll call this corner 0. So that's plus 35. And these measurements are in microns. Okay, 30 plus 34. Ouch. Okay, so that's a terrible result for a surface grinder. You know, over that little distance, a well-adjusted surface grinder should be able to grind within probably 1 or 2 microns, I'm guessing. Okay, so I've put my micron reading clock on here. First, let's look at the cross slide travel. Oh, wow. Okay, I've lost contact and now, oh, it's going back up again. That looks like the highest spot, so let's 0 there. And the lowest point, we've got 1/10 of a millimeter. Wow, that's so terrible, it should be visible with the naked eye. Yeah. Okay, and just to confirm, there's my 1/10 of a millimeter feeler gauge. I mean, I knew I was going to need to resurface this chuck, but I was hoping it would be less bad than that. It seems bowed side to side along pretty much its entire length. This chuck, as it's currently mounted, is unusable. I'll take it off, give it another good clean up, because it's not impossible that it's bowed because I'm pulling down on the middle and I got something stuck under the edge or something. I mean, I did clean it before bolting it down, but I'll just check that. So it's coming back off and then we'll look at the table. Right, but before I lift that heavy chuck, I better switch over from those shoes to the ones that don't have the holes in the heels. Oh yeah, and also have steel toes. Now there shouldn't be any burrs because I already stoned this before I put the chuck on. Right, so what does the table look like? Okay, that was a rise of 1/100th of a millimeter across the travel, which is not ideal. We saw 10 times the error on the chuck just from the center to the edge because it was going in each direction. So table sloping 1/100th of a millimeter from back to front. Let's look at side to side. It looks like, yeah, I've also got roughly a bit under 1/10 of a millimeter left to right. As the rack and pinion changes direction, as it engages, it pushes up on the bottom. We may well find that that doesn't happen under hydraulic control. Whoa. Okay, so as we hit the end of the travel, it goes crazy, which is also where it binds up. Whatever's causing my binding is also causing the table to lift up. The table, for the most part, is within 1/100th of a millimeter. Over the small areas that I'm looking at using it for at the moment, it's not great, but it's something I could probably live with at the start. So the chuck is way off. Now the good news is, I actually got 2 magnetic chucks with this machine. The bad news is I just carried the heavy one in, plonked it down on the table, and it's got enough rest magnetism that even in the somewhat off position, it's sticks pretty hard. Let me put some bit of wood or something down. Now this came off the pallet from Malta like this, so I have no idea why these screws are sticking out. I have no idea whether somebody started disassembling it and got stuck or what the story is. Looks like this chuck's not going to be a quick solution to my problem. Okay, so this is the only screw that moves, and it only moves because its threads won't catch. All of the others are really tight. Oh, that one's moving. I really hate slotted headed screws for this sort of thing. I thought I had an impact screwdriver, but I don't know where it is. So it looks like these are all loose, except for this one, and those two are jammed. Given that these screws are obviously fine thread, I'm going to guess British standard fine. So we know where this is going, don't we? I'm going to end up having to make new screws. I'm sure I'm not going to get all of them out, but I'll do my best. I'm sure I had an impact screwdriver somewhere, but I can't find it. Let's try this. That one's moving. I did find my impact driver. Now I don't have a step down from 1/2-inch drive to bit. Can't use that today. All else fails, I'll go to the hardware store tomorrow and see what they have. Now I'll just use a drift, both to try and shock the thread a little, but also to knock down the burrs on the driving slot, because maybe that could help a little. Okay, that's not going to do it. I need a better bit. In the meantime, let's just see if we can scrape the worst of this rust off. I used to have a big screwdriver, but I lost it. So now I bought a new one, a Wera. They're supposed to be pretty good. Oh, yep, there we go. So, one more. This is, of course, the one that's most buggered up. Yes. Well, 2 thumbs up. Wera number 334. If you can get these in your area, highly recommended. I like how it's got the little grippy grooves on the end here. Seem to work. I'll leave an affiliate link below if you can get them in your area. Right, so now we're all wondering, what does the mag chuck have in it? Right, at the moment I've kind of reached the limit of what I can do with that magnetic chuck. Ah, it's an Eclipse. Made in England, type N. Does anyone know how to disassemble a permanent magnet chuck which is stuck in the magnetized position? Right, well if the big chuck's going to be a bigger project, let's have another look at this little chuck. Now if this is sort of a dished valley, theoretically if I place the block in the right position, I should be able to get it neutral. I know it's not a very good or accurate way of doing things, but hey, you've got to work with what you've got. I guess you're supposed to dial this in along one edge to get it square, but for now I've got no need for that. Now obviously I could just regrind the top of this. But I'm kind of loath to do that until I really get a good feel for the accuracy of the rest of the machine. I don't particularly want to start grinding the top off. On the other hand, we're talking 0.1 of a millimeter that needs to be removed, and the table's still 18 millimeters thick, so really wouldn't be the end of the world if I have to do it a second time later.
I need some of these, please, for my drip watering line, and they don't make them anymore.
Just wait here a minute, I'll be back. I had to simplify the design a bit for 3D printing, so basically it becomes kind of 1/2 of the original. And once you've got one, you can have many. So I sent those off to my Bamboo Labs X1 carbon to print, and they were done in just a bit over an hour. I redesigned them a bit because I wanted them to sort of clip the line down to the dirt. What do you think?
They look cool. Finally something useful from a 3D printer. Hope they work.
I hope so too.
I like the way they come off.
You can take the other ones off.
Very cool, thanks. So let's try this. Looks good to me.
Cool. Since all of my wheel hubs are really rusty, I think I'll give them a quick clean up. Okay, so that was a 60 grit wheel. Thought it was kind of fine. Just whip the balance weights off. That's a little dovetail. So you've got these little dovetail edges. Each has to be put in individually, and once they're locked together with the screw, they can't move. Now for rust removal, it was recommended I try out the Beyond Ballistics recipe, which is for a litre, you want 100 grams of citric acid. I'm only going to make a half recipe here. And then you need 40 grams of wash soda. Wonder if I'm supposed to dissolve that completely first. Right, now I can add the wash soda to it. This should react somewhat. Yep. Whoa. Okay, don't stir it, it just blows some out. In fact, it blew quite a lot out. Oops. Guess I should have added that a little slower. And my batch is now going to be less concentrated than it's supposed to be. The last ingredient is just a little bit of normal dishwashing liquid as a surfactant. Kind of feels like I've still got some chunky bits on the bottom there. Right, so these are the first bits to have their rust removed. Oh yeah, there's some chunky bits stuck to the bottom of the glass by the looks of it. See if I can dissolve those out. Supposedly this should do its job in sort of 20 minutes or so. Guess we'll see. Right, how does this work? Well, it's looking pretty good. What little rust is still on there just wipes off easily with steel wool. Oh wow, yeah, that really is awesome. Just leave that in there for this time being. What about the big one? The first thing that a rust remover removes is the bluing. A bit more rust on this one. Still mostly popping straight off, just a very light rub. This one's really got some quite deep pitting on it. Right, since this one's finished, to neutralize it, I'll just put it in the sodium hydroxide bath. Then I'll just rinse it off with some fresh water and then go over it with the dewatering fluid. These were rusted in before and I couldn't budge them, but now they're going okay. Give those a bit of a tap. So look, my chemical rust removal worked really nicely. Still a bit pitted.
That looks pretty cool.
Yeah, unfortunately the fourth hub, which was given to me by Tim in California, doesn't actually fit this machine.
Oh well, I guess it just means you have to buy another machine.
Can I have that in writing?
No way.
Right, now they're all cleaned up, I can see that they're all also somewhat different. This one, for example, has got no keyways milled in through the threads. It also has no way of balancing it. This one has balancing on the nut and nothing on the hub. Whereas this one's opposite, it's got the balancing on the hub and a much lighter nut. One thing that is interesting is this one has a part number. I'm pretty sure that's an original part from Jones and Shipman, so that's going to be the one I'm going to copy. So it's quite convenient that at the moment I have 3 hubs and 3 grinding wheels. I tried to Google this. I can't find anything about this as a grit. It's obviously a 46 grit wheel. I think F means it's quite dense. This blue wheel is also TGP, also a 46 grit wheel, but the 11 in there means I think it's less dense. It's got more porosity to it. Again, couldn't find anything much about that. And this wheel here, an A60, so it's a finer grit, and I'm pretty sure that A is aluminium oxide. I'll mount the smallest wheel on the unbalanced hub. Oh, I've just noticed there's a part number on that nut. So that seems it should be paired up with this one. There was some speculation on the Air India Dreamliner crash that the RAT or ram air turbine might be involved. I thought I'd show you one. These are an independent power source for the flight controls. It's kind of their primary role. This is a 757, so it's a hydromechanical flight control system, and therefore the RAT is driving a hydraulic pump. There's this big actuator to make sure it deploys at speed. It's basically just a little windmill with a constant speeding unit and variable pitch blades. On some aircraft it drives a generator, and on some it has both a generator and a hydraulic pump. Right, so today I'm here with my mate David, who's just a fantastic machine restorer. We've just done a quick job on a shim for his drill press, right? Yep. But now we're going to quickly pull the magnetic chuck off, pull the table off, and just have a quick look at the geometry at the ways of this machine. So one of the things we're looking for here is, why does this table stick at both ends of travel? I need a bit of a help. With the piston in the middle, it's moving smoothly. I'll slow it down a bit. So when we come to the end of travel and reverse, it's stuck. Okay, so it looks like part of the problem is what I did when I replaced the piston rods. So I'm going to need to strip that system down again and have a closer look at it. But let's take a quick look at the ways. So it should hinge in the middle, huh? Yeah.
It does, which confirms the straight edge is straight.
Yeah. Well, straighter than the ways. Interesting that we picked up a few spots, yes, but not.
Oh, there's a burr on the very edge.
Yeah, I'll get the stones.
Next, David's checking the gap between the way and the straight edge with a 15 micron feeler gauge.
Ah, no, this is an imperial set. Ja, genau, this is ja, nicht metrisch.
Also es ist Verschleiß ist wenig.
As we can see here, although this is a very, very heavy coating of ink, we're looking like it's not a terrible amount of wear. It is slightly curved in this direction. We can tell that by the wear on the ends and the scraping marks still visible in the middle, but it's definitely not terrible. That's good. Should we also print these ones or pointless?
Give it a try.
So pretty much the same wear pattern shows up on the V-ways as well. Next up, we turned our attention to the piston and its rods using the straight edge and some V-blocks with an indicator, and what we found is it wasn't all nice and straight.
Okay, so looking at the concentricity of the piston against the push rod, this one doesn't look too bad.
This side looks pretty good.
The other one's going to look terrible.
And it also turned out that one of the piston rods I made was made from a slightly bent rod.
As the machine is still sitting on a pallet and very flexible, we're going to have a little go at seeing whether we can get any information on how straight the cross travel is, using one precise level to measure deflection and a second precise level to see whether any deflection we get here is just because the whole base of the machine's tilting.
I think it would be nice if I put it here.
Yeah.
Problem is I can't read it.
No,
Maybe with a mirror.
This is a pretty low resolution machine level. We think it's 1/10 of a millimeter per dash over that length. But taking a quick look at it, there's nothing really to indicate that the ways are horribly worn, but it's only a very, very rough measurement at this point. We would need a second and much more precise level to get real data out of this. This is my other straight edge. This is just my triangular one. I'm not exactly sure how straight it is at the moment, but if we check this out, David's going to show where it hinges.
Oh, wait a moment. I think you put some dust on there. I cleaned it one more time.
More grit on there. It's so easy to get a little dust particle.
Okay. So straight edge is straight.
Yep.
Oh, pretty straight. And it looks like the table might be a little bit high in the middle. But if I warm it up just a little bit, it hinges on the ends.
Wow, that goes so
Which
quickly, huh?
tells me straight edge and table fit pretty good together. Should be flat enough.
Cool. That's amazing. Just that 1 or 2 degrees is enough to change the curvature of the straight edge that much. And you move from a hinging here right out near the ends. But we won't bother bluing that because that tells us enough already.
We then shifted our attention to that magnetic chuck.
Okay, so this is the print with the magnet off. We'll do it again with the magnet on.
It seems to be much more convex when the magnet is on.
Oh, okay.
It feels very different. It almost looks flat now.
Yeah. Do we put this on, block it into position and grind the back first?
I would.
You would do the bottom first.
Yes.
So then we got the question of, so how do we hold the thing down? Because if we magnet it down, we know we've got this huge hollow.
Maybe we could try to find out how much shims we would need to place in the middle, so that it has contact on the ends and in the middle.
Yep.
So it doesn't flex so much.
Okay, so what we're going to do is grind the back of this, flip it, and then grind the front.
Right, once we finished the rough grind, we took a lunch break to let it cool down. Although this wheel grinds very cold, so it wasn't a problem. After lunch, we still got a pretty bad surface finish, even with a much lighter grind and much less step over.
Okay, that's not looking perfect, but it's good enough to flip it over and do the second side. Grinding a magnetic chuck is with the magnets on, I believe.
Now with my mag chuck this way up, I can hold my dressing diamond and dress the imbalance out of that wheel. It gave a much better surface finish after that. The powered down feed on this is fantastic. Hey, if any of you'd like to speculate how a magnetic chuck ended up with such a deep valley across its surface, I'm all ears, because I simply cannot understand how anybody who owns a surface grinder could let this tool get into this condition. It really takes a while to remove over 1/10 of a millimeter. I don't yet have much of a feel for this machine, so I don't really know how much is too much in feed, so I tend to take pretty light cuts.
Well, this is now starting to come in quite nicely. There's still a wee bit of corrosion and scratching through the middle, and then this bit to grind down. Unfortunately, I got chatting with David, and then we got into a bit of a show and tell and all sorts of things, and I completely forgot to thank him for his analysis of this machine while he was here. I would like to say that. Thanks very much, David. It really helps having someone with your expert eye take a look at the geometry. Right, I think that's cleaned up pretty nicely. There's just a wee bit here on the very end, but hasn't cleaned up yet. I'll just dress that wheel again. Now for this final cleanup pass, I'm going to reduce the step over a bit. Right, with that chuck now looking a lot better, I think what I'll do is just do a quick check. This is a block which I ground while I still had the chuck completely hollowed out. And you can see from setting this corner, I had plus 34 microns, 40 microns, and 60 microns. So let's just regrind that and see how much better it is. Right, time to measure that up and see what it's like now. I don't really like the surface finish I got on the first side. The second one's got a finer pattern. Right, how does this work out? I didn't bother trying to grind it to any specific dimension. So 48,809 can be my 0 point. Okay, there I'm a micron smaller. Same.
All right.
Right, let's take a look at this on my comparator stand, whatever these are called. By the way, when I overhauled this, I'll leave a link to the video up here. I got a lot of feedback that I should have checked the perpendicularity of this bar relative to the table, which I didn't do. In a way, they're right, because looking at it, it is nowhere near perpendicular. However, it doesn't actually matter. All you're doing here is you're putting a point in space above a flat plane. Now, this plane's not flat, so it's got its own issues, but how that point in space gets mounted is completely irrelevant to any measurements. And there's no form of anti-rotation device, there's no sort of rack and pinion, so you can't use this as a sort of hold in alignment while you measure one thing, move this head and then measure again. That's not a thing with these. So it's pretty irrelevant that this is angled way off perpendicular. So how do measurements on this compare to the micrometer? Well, if I just start with this first corner and just simply rotate the block around under this pretty much the same spot, there's already 2 microns of variation. Considering my micrometer readings were within 1 micron, this gauge is going to be somewhat useless until I flatten its base. So here I measured -1 and it's showing -3.5, -4. This was measured at 0, and moving things around I can get any value I like between +3 or so. 0. And moving now to the last corner over here. Once again, it measured 0 on the micrometer. And you can pretty much pick any measurement you like just by rotating it. So at some stage, this needs to go onto the surface grinder and just needs this table brought to a single flat plane. Right, so I guess the next test to do is the 5-point test. So plop down 5 identical washers. These are just nothing special. Ah, okay, that one's not the same. That's a stainless washer. We'll just grind the first face smooth, flip them, clean them up again, and see if they're all even. Right, let's go measure those and see how even they are. Well, first up, let's zero out on the center one. Okay, it's also 0. Just measure that again. So have I understood the 5-point test and how to perform it correctly? Seems pretty reasonable to me. Definitely the most accurate machine in my shop at the moment. Okay, so it looks like grinding that magnetic chuck-ins made a tremendous difference. That's great. Right, well that makes me really happy with that surface grinder. With this level of accuracy, plus minus 4 microns, it's definitely the most accurate machine that I own, and over small distances it should be more accurate even than that. Obviously I've still got some issues to work through, especially around that binding at the end of travel. I think it's a combination of like a stack up of tolerances. There's a little bit of a bow in at least one of the 2 hydraulic rods that I bought. Maybe the threads I cut are not perfectly concentric with the rod, or another issue is I reamed out the guide bushings from 3/8 of an inch to 10 millimeters, and I did that by hand. It's possible that I got some off-axis pressure and I've now got a slightly misaligned bushing. That could also contribute to the problem. It was a nice confidence boost that someone who's got some real experience with scraping in machines like David took a look at it and also came to the same conclusion that the ways have a maximum wear of about 15 microns. I can live with that. Sooner or later I would like to overhaul the machine, but first I'd like to use it. So there we have it. I think the next major mods on that machine are going to be adding linear encoders so that I can actually read out metric dimensions on it. That would be quite useful to me. I tend to make way too many mistakes in the calculation of metric imperial, so that would be an improvement. But other than that, I think I'm just going to use it for a while. Anyway, thanks a lot for watching, and I'll see you next time.